Welcome to the fourth problem-based tutorial. In our previous two sessions, we made some important measurements. In this tutorial, we will take additional measurements on the same circuit, that is, the half-wave diode rectifier. Problem statement. Make the following measurements while simulating a half-wave diode rectifier circuit. Number 1, instantaneous power. Number 2, average power. Number 3, apparent power. Number 4, power factor. Getting started. Let's begin. Launch Simulink by clicking the Simulink icon in the toolbar. Let's open the model we created in lecture number 2. Save the model. Click the drop-down menu next to the Save icon and select Save As. Next, give a proper name to your model. Instantaneous Power. Double-click the diode block and disable the measurement port. Also, double-click the series RLC branch, select RL from the drop-down menu, and click OK. Remove the multiplexer block. Now, open the library browser to bring in a product block. Add this block to your model and connect it into the circuit. Connect the circuit current and the load voltage to the inputs of the product block. Rename the scope. Now click Run to start the simulation. This is our instantaneous power. The graph shows us the instantaneous power. The value of power at any specific moment in time is called instantaneous power. Find average power. Let's bring a mean block into our model. To find the average power, connect the instantaneous power to the input of the mean block. Double-click the mean block and set the frequency to 50 Hz. Now bring a display block and connect it to the output of the mean block. Name the display block as average power. Now click Run to start the simulation. The display block shows the value of the average power. Measure apparent power. We need a voltage measurement block to measure the input voltage. Copy and paste the voltage measurement block and connect it across the input voltage. The apparent power is calculated as the RMS value of the input voltage multiplied by the RMS value of the circuit current. Connect an RMS block at the output of both the voltage measurement and current measurement blocks. Find the product of the two RMS values. Check the required box in the block dialog and click OK. Do the same for the other block as well. Now, bring a display block, copy and paste it, and rename it as Apparent Power. Click Run to start the simulation. The display block will show the value of the apparent power. Calculate power factor. Now we will calculate the power factor of the circuit. Bring a divide block. The power factor is equal to the average power divided by the apparent power. Make the required connections and connect a display block at the output of the divide block. Rename this display block as power factor. Now click Run to start the simulation. The power factor is approximately 0.7. Summary. In today's lecture, we made several important measurements, including instantaneous power, average power, apparent power, power factor. Thank you for being with us.